Are you interested in integrating drone technology to enhance your students' learning in computer science? I'm Ethan Pan. On today's Pattern Pop-Up practice, let's explore how drone technology can support CS education and engage students in meaningful hands-on learning experiences. Pop-Up practices, where practice makes progress. Season 3. First, what is a drone? Simply put, it's a small unmanned aircraft system, often used in real-world applications such as delivering packages, monitoring environmental changes, and mapping landscapes. So why should we utilize drones in the CS classroom? Drones, like many physical computing tools, provide hands-on learning experiences that make abstract CS concepts tangible and engaging. With drones, students can code flight paths, collect and analyze data, and practice CS concepts such as loops, conditional statements, and variables. Incorporating drones can also expand access to CS education by providing exciting entry points for students who may not traditionally engage with coding. Let's look at some practices and strategies to help effectively integrate drones into your instructions. Practice number 1, connect CS to the local community. How can you incorporate your community's cultural wealth and local funds of knowledge to make your drone lessons relevant to your local community? Use real-life examples to bridge the gap between the classroom and the community. Consider inviting local partners or visiting nearby facilities, or discussing and simulating real-world scenarios in the classroom. For instance, discuss how drones are used in agriculture to monitor and trip crops efficiently, or explore how drones assist in locating and rescuing objects in hazardous environments, such as during natural disasters. Drones are also critical for infrastructure inspections, like monitoring bridges, buildings, and power lines. Practice number 2, playing with the background design approach. Focusing on overarching learning goals and assessments first make it easier to design meaningful activities that lead to effective learning outcomes. Use the Understanding by Design UBD framework to plan your lessons. Start by establishing goals and lesson objectives. Identify the concept and skills students will learn. Ensure alignment with CS standards. Begin with an unplugged activities, then transition to plugged and hands-on physical computing activities to scaffold students' learning before incorporating drones. Remember, the focus is not just on drone technology. They are fun, but what truly matters is what students will learn, the concepts. You can use different tools, programming languages, and platforms to teach the same concept and skills. Practice number 3, fostering social-emotional learning and career readiness skills. Incorporating drones encourage students to develop essential soft skills. These activities inspire collaborative teamwork as students build drones, plan, test, and refine their code. Along the way, they strengthen communications, problem solving, and leadership skills. These are core CS practices as well as key traits for success in any career. Practice number 4, integrate across subject areas. Drone technologies offer incredible opportunities for interdisciplinary learning. By using phenomenon-based, project-based, or inquiry-based approaches, a drone project can be integrated across multiple subjects. A drone lesson can address both CS standards and Pennsylvania steel standards while connecting with a wide range of other subjects. For example, in technology and engineering classes, students can dive into the engineering and design of drones. In math, they can focus on data collections and analysis. Physics classes give students the chance to explore the science of flight. Social studies provides a space for exploring the ethical consideration of drone usage. And in art classes, students can explore drone performance and creativity. The possibilities are endless. Practice number 5, ensure accessibility. We need to ensure accessibility when integrating drones in lessons so that all students can participate. By applying Universal Design for Learning (UDL) principles, we can proactively remove barriers and make the learning experience more inclusive. For example, choose accessible programming languages and platforms, and use adaptive controllers or helping hands to support building, flying, and coding drones. The more you know about your students, the more inclusive and thoughtful the lesson will be. Check out our PaTTANpod video series, where teachers and students discuss using drones in spatial education settings. From 2021 to 2024, the CS in PA team has engaged 5 cohorts in the Drone Professional Learning Program, involving approximately 70 local education agencies and intermediate units, 154 educators, and 937 students. In the video description, you will find a link to a Pennsylvania map showing LEAs participate in the drone programs and the IUs involved in the statewide drone trainer program. We encourage you to connect with neighboring school districts or local IU facilitators for collaborations, support, and technical assistance. Thanks for joining me on today's PaTTAN Pop-Up practice, where practice makes progress. Produced by Kat Zimmerman and Connor Strategos. Be sure to like this video and subscribe to our channel for more.